Here is the, let's draw that circuit again. So here's the battery, and here's the light bulb. Let's assume that it's the same type of wire throughout the entire circuit, right? So the wire here has some electron density N, and it has some electron mobility U, okay? It's copper or something, so we can look those up in a table or something and find out what they are. So we can say that, okay, the current at A is equal to the current at B. I also know that I is equal to NA V, right? So let me plug this in. The electron density at A times the area of the wire at A times the velocity of the electrons at A is equal to the electron density at B times the area of the wire at B times the electron drift speed at B, okay? What's the same on those sides, on those equations, or on both sides of that equation? Okay, the area is the same. It's the same thickness of wire, we're assuming. So they would cancel out on both sides. And N is the same, right? The number of electrons per unit volume is the same because it's the same material. Copper, for example, on both sides. So what we find is that, in fact, the drift speed, in this particular case, turns out to be the same as well. If you have the same thickness of the wire and the same number of electrons per unit volume, then for the currents to be the same, you have to have them moving at the same speeds too. So that's a good question. Other questions here?